Ladies and gentlemen, we have heard two excellent presentations, and by coincidence I haven't seen them before, but my presentation is about how we can make it happen, how we can use the best natural processes in planning the future cities and then increase the resilience. Use all the current state of the art of modeling and design in designing and planning for the future cities. This is about me, and this is just a brief introduction. I'm mainly going to talk about the project called Blue Green Dream, and there are a few brochures about the project. This project is funded by the European Institute of Innovations and Technology, and we have 5 leading European technical universities. We have leading consulting companies, architectural bureaus on board, developing methods how the cities of the future should look like. Blue Green Dream is blue is about the water infrastructure, green is about the green areas in the cities, and dream is how the cities should look in 10, 20, 50, 100 years from now. The issues we are facing are already mentioned in the previous speakers, but just you may not know that London is losing every year, every single year, 2.5 Hyde Park equivalents of green space. You can imagine Hyde Park, next year 2.5 Hyde Parks gone, and in 10 years 25 half Hyde Parks gone from London by simply paving bit of access to a garage and so on. If something is not done seriously, systematically, on long term, we are facing much faster impacts of the climate change. And we have all these problems which are poor drainage, floods, droughts, tidal surges. New York has been hit by tidal surge, heat wave, cold wave in one single year. Current philosophy is fragmented, designs are fragmented. We are seeing no interactions between different specialists, even the same company, often inefficient, over-designed, high vulnerability buildings. Climate change, but not just climate change, as two speakers said, extreme weathers is going to make things much more difficult, and we have to do something now, not in the next few years. And this is not only we should do something, this is how we should do it and how we are already doing it. You've seen the calamities in New Orleans, in Seoul, in Beijing, Fukushima, New York. London was lucky to avoid it, but question is only for how long. You may know last heat wave which hit Paris area, few tens of thousands of people died in just 3 days. Not in Paris, but also in north of Finland, which is close to the North Pole. Heat wave, only 2-3 degrees makes a big difference, kills thousands of people. Do we have our cities ready for this? No. We have to change not only how to design new cities, but also how to retrofit existing ones. Just to illustrate, I came from India to last week. There was a consultation with British and Indian on how to design future cities. India is planning to build 430 new cities over 1 million. Can you imagine? 403 from scratch. China, I'm going to China in 2 weeks to consult with these Chinese planners. 340 new cities over 1 million from scratch in the coming years. And this is just illustration of these 2 big countries. We in Europe don't have to go that way, but we have to do something significantly different than what we are doing now in terms of how we retrofit cities and how we plan. Well, why we do it? Well, Blue Green Dream, or we call BGD, and I said to be GD or not to be GD, it's not the question. If you delay it, you'll face serious consequences. It has to happen one way or the other. We call it green cities, green infrastructure, resilient, intelligent cities, whatever. We have to do something differently than what is being done now, and governments have to have consistent long-term policy. At the moment, everything is fragmented, everything is short-term, everything is up to next election survive. We do need long-term vision, and this is missing, and this project is about this long-term vision. It is not just about the few degrees of temperature rise by the end of the century. It is what we are seeing now, every year after year. We have much more rain, it lasts longer, we have much more dry weather, and you've seen last year only here in London area, we had very severe drought, and then floods. They say it is the wettest drought in the history. It's going to repeat year after year, and it's going to be more severe. We had to do something serious. If you look at the Charles Darwin theory and the evolution, we think we are somewhere here, but we are not. We are facing the problem, and I think that blue-green philosophy has some kind of solution. I'm going to present you briefly what we mean by that, and how every single house, every single street, every single park, every single city, every single country in the world has to go. It's not just provide drinking water, sewage, and drainage. This is the first three lines. We have to do much more. In the past, we thought that's enough. Cities are becoming more vulnerable. We have to do a lot with the natural processes, and we have to become more resilient, less vulnerable for the changes, and this has to happen now. How we do it? Well, we have seen from the previous speakers, it is not only building. Buildings are just an element of the urban fabric. We are facing all these severe ecosystem services like thermal biodiversity is an important element. If you don't have enough bees to pollinate, our vegetation may die in many aspects. And so it's noise, it's air pollution, it's the flood risk, it's the aesthetic values, health diseases, all this mutual interact. At the moment, we have specialists dealing with the silo. Everybody does a little bit and no interactions. We are facing problem of the building something which is expensive, inefficient. Interactions has to take place, and this project is about how do it differently. And it's not just flooding and droughts. These pictures are from London, mostly. Area, and just a few weeks, the whole South England was flooded, and then the droughts hit last year, and then the water pollution. UK is going to be fined by the European Union by 1.3 billion pounds because of the polluting Thames, because whenever it rains, these combine also throw 40 million raw sewage in Thames, and this is a problem which current government trying to solve in a way which I think it should be done differently. You have this, Vancouver has been mentioned the city of producing food. In the future, cities will have to produce 30% of the food. Roof, terraces, balconies all over the place to survive. Noise, air pollution, heat island, and so on. It is not something happens in the faraway places. It happens here as we speak. So how we do that? Well, flooding is not something that you see these days, this what I call flooding tourism. Big guys go there and say, don't worry, we will do something quickly. It doesn't work that way. It has to be something long-term, consistent, and it's not just you build a bigger flood defense or bigger pipe to drain. It has to deal with all other aspects. Green roofs are not to be green. Green roofs can collect water, as mentioned. You can use this water for toilet flushing. If you use rainwater for toilet flushing or grey water for toilet flushing, you reduce pressure on your water supply system. You need less water, and so on. Then if you have more water, you use it for irrigating your vegetation. Your vegetation evaporates. Evaporation can cool facades, and so on. It is all mutually interacting, and this project is about how we take these interactions. If you just take wash machine and your bathroom, you take a shower, and throw this water away. It does not work anymore. Florida, California are facing severe problem these days as we speak. No more water from Rocky Mountains area. England, here where we speak, last year, you know what happened just 2 weeks before Olympic Games, the restrictions have been. So this water we just throw away. Rainwater we throw away. We are wasting it. It's no more future. In the future we have to collect it, recycle it, and make best use of it. Heat island has been mentioned here. You see this building thermal image. Roof is very hot, and that if it's not properly insulated, it goes down. And if you see, green areas are often 10-15 degrees lower temperature than facades and roofs. And we can rely on these natural processes to design our cities differently and retrofit differently. Trees, humble trees, are not just there to give you shadow and biomass. If we use trees properly, trees can be planted. If London is planting millions of future trees should be planted differently. Planting tree with a small reservoir which can capture the runoff from the street, store it there and use it for evaporation, cool the city, and then reduce flood risk and so on. So just whatever you do, don't do it just single-minded. Do it multilateral thinking, and you have tree, when it evaporates, hot air goes up, cold air falls down. It can, if you just plant it differently, it can cool your facade, and we may not need all these air conditions which just pump additional heat. So cities should be done differently, planning and retrofitting. It is not cheap, but we have no alternative. It has to be done differently. So there was a philosophy that said green cities. Well, green cities were mainly designed to create green corridors that foxes can run from one part of the city to the other. Fine, cyclists can run, yes. But now we have to think differently. This green infrastructure can have many other functions. When it floods once in 20 years, where this water doesn't have to create millions or billions of damage, that water could be played around, and green spaces are kind of temporary storages and so on. But that has to be known how it works. All these functions have to be known, and then we do different. At the moment, take this simple house where my speakers have presented, previous speaker. We used to bring water and energy and food and heat and cooling and then throw the rubbish, wastewater, food waste, solid waste, everything. So we have horizontal flow of resources and creating a lot of rubbish. To continue this way, we need 3 or 4 planet Earths. We have only one, unfortunately, and we have to do something different. So replace this horizontal flow of resources more vertical. We can collect roof water, toilet flushing, and you see in this exhibition many of toilets differently designed. And then you can create, produce some energy, photovoltaic. In summer when it's too cold, you don't panic. Store this energy underground, and rock it in foundations, and then recover it in winter, and do it systematically through year after year. Wastewater, hot water is energy in it. You can capture it, reduce it. And you'll see in this exhibition many bits of pieces already emerging. But this is a bit more patchy. If you do it systematically on the whole city, then we have different philosophy. And then we manage not only buildings, but green spaces, streets, transportation, energy efficiency. This becomes part of the whole. The Blue Green Dream project is about how to plan it differently, and I'll give you some examples. Not only for buildings, but also biodiversity. As you have seen, if we are losing all these, if we are going to lose 25 Hyde Parks equivalent in the next 10 years, if you don't do something significantly different than what you're doing now to increase biodiversity, start putting beehives on your roof and have more bees around. Honey produced in the city is much more healthier, doesn't have pesticide. Sainsbury produced first 40 kilos last year. They plan maybe in 10 years all the honey which you buy in Sainsbury's will be produced on the rooftops of their supermarkets, maybe, if they follow what we are advising them. We have the just first beehive on top. So if you put all these icons on top of each other, we have, at the moment, you have specialists dealing with each of all of these aspects separately. This project is about integration at the moment, and we have these 5 leading European universities. We are trying to learn what we don't know, how to plan differently, how to design, monitor, manage, and how to do it in an integrated fashion for the cities of the future. We have these 4 countries, UK, France, Germany, Netherlands, and we have London, Paris, Rotterdam, and Berlin as demo sites. We already have some demonstrations how this planning should be done, but this is just the beginning. We are creating Blue-Green Center in Scandinavia. Scandinavia is different climate, and they have to adapt these technologies differently, and then Central Eastern Europe differently, and Middle East differently. This is Europe. 5 Blue-Green Dream regional centers are being created, and we are also next phase is to deal with something on the global scale. We are working with India, China, Singapore, Australia, South Latin America, and Africa, and this is gradually gaining momentum, but we have to do it wisely because the resources are limited. Nobody has that much money to deal with one single item. And I'll show you an example of what is happening as we speak these days. Consultation about tunnel in London, which is going to cost 5 billion, and I think this money can be used. And everybody, my pocket, my children, my grandchildren will pay it for next 70 years for just one tunnel, which this money can be used differently and spent better. Okay, at the moment, this is not something which happens overnight. We have to know as we speak the new methods of planning. We have to train the planners, designers. We need models of the future. At the moment, I'm having 17 doctoral students in Germany, France, and us, developing new methodologies of planning, and we also at the same time work with the planners, designers, how to implement it as we speak. What is state of the art, and the models of the future will be done in the future. So this is what is happening. We developed what we call integrated modeling system for optimized design, that we can design for resilient and better places in the future. Everything we build in the future must be more economic. It's easy to spend 5 billion for tunnel, great project, but then you will have no money for air quality, you will have no money for other aspects, because this money will go from our pockets, and our pockets, as you said, not very deep. So we have to look at the buildings which are cheaper to build. Everything, not buildings, parks, streets, railways, anything. It has to be lower operational costs. You will live in this building, you have to pay less for water, energy, heating, cooling, everything lower. And these properties have to have much higher market value, be nice and green, and in using all these natural processes. Just solar energy is not always enemy, it could be friend. Rain doesn't have to be enemy, you collect it and it's friend, and so on. And higher market value of the properties. So it is also increasing green credentials, not only of the buildings, of the cities, of the Bristol and the other places. We have an excellent examples of Vancouver. Every single house can do it, and every single house will have to go through it, whether you insulate your walls or they'll do something. But if you do something now, it's better to look what else can you do. Planting trees, not just planting tree, but do it in a more organized and more integrated way, because all these things interact. And what we are doing at the moment in terms of research, we look at these interactions, how they function, how they quantified, how they can use these interactions for optimizing better design of houses, gardens, streets, infrastructure, water, parks, and so on, and then get these natural processes to work for us rather than being our enemy, not to kill us, but just improve our standard of living and improve our energy efficiency, our resilience, and so on. So this is a philosophy. I'm not going to talk much about this because it will need another day or two, but this is just new method of changing our mental setup, not only ours, but our planners, and it should be by politicians. Unfortunately, politicians are a bit slow to capture and to change their philosophy, their party manifestos, their future. Those who accept this are much better positioned to be. If you don't do it like it's done here, let's just look at the very similar approach, but if you don't attract all these interactions, immediately end up with these red circles, which are higher costs, low energy efficient, less pleasant to live in these houses, and so on. This is just what we call this three-legged dog. If you just lose one of these interactions, immediately you will create not optimal solution. It has to be done in a little bit of. So I'll give you a few examples. How we can do this new development design, how we retrofit existing buildings, and then how we optimize this. Well, this is an area in Paris where we worked with. It's near motorways, noisy, and it's a railway system very noisy. So we can use green infrastructure to reduce noise. We can, with trees nicely planted. Not the best efficient, but you don't just use trees for noise, but you also look at the other examples. The Copenhagen Opera, which was designed, if it was designed to have natural ventilation, it will have to be closed the first day after opening because of the, you see this red area is the air contamination, air pollution in front, because they've closed the natural ventilation process and they've created a pocket of highly concentrated air pollution. And you can imagine opening the opera and people start coughing during the Aida. Our people did some modeling and they had to redesign, just make more opening, and then the nature will clean it. We don't have to use a lot of energy and so on. Just after the design, but you have to know how to do it, how to predict, and so it's not just you do now, as our speaker said, you do it, what will happen next 20, 100 years, and so on. This is another example. It's the new university campus in one of the European cities. It's a 1 billion project. Architect who worked with us won the first prize, not because of the buildings, but with the way how we incorporated green spaces. Every tree has a story. How tall is the tree, how big is, how you orientate it, how you use the wind breeze in summer, cool the facades. And it turns out, after design, 46% of energy saving in summer instead of air conditioning. Just, it's happening by itself. But you have to know how it works, you have to know how the winds blow, where it's from, which direction, summer, winter, and so on. So it's a different way of designing, using green infrastructure to design differently. Architects who were unknown, much bigger sharks were around, they got the first prize because, and the chairman said, oh, we haven't never seen such a nice design. It's not just architectural design, it's the how to use the natural processes to make it nice. This is a green, supposed to be green roof in the École Nationale des Ponts de Chaussée in Paris University campus. It has been changed in the last minute, turned into biggest open air laboratory. How we use these processes, rainfall, runoff, infiltration, saturators, and then how all these processes, cooling, heating, can be implemented. This is the biggest research open air laboratory in Europe. And then there's another place, X, working with British colleagues, architects, the different city of the future, blue-green city, where no single drop of rain leaves the area. There is no storm drainage. There is no grey water drainage. Everything is captured, recycled, and used for improving the energy efficiency, recreational spaces, and so on. And it has to be cheaper and efficient, lower bills, better market value. City of London, these are two examples from London. City of London, Cheapside Street. If you go to city, if it doesn't do something significantly different, will lose its primacy. If you go there in summer, it's very cold, you are perspiring. You cannot go from tube station to the bank because it's hot in summer. The answer is we will put more air conditions. Put air conditions and pump more hot air in the streets, it will be even more. Use the natural process, but we have seen some projects say, plant more trees. Well, plant more trees, more green roofs. But it's not just random. You do plant, but you have to model, predict, and see, does it really work, and quantify, and so on. So blue-green is about all this integrated process in quantification. Victoria Station is now undergoing reconstruction. It's called the BID, Business Improvement District, and how to do more green and so on. But again, just putting some trees, putting some green roofs, and that's it. It's not like that. We have to see what the impact is, how much you benefit. And we've done some analysis. Do you really increase? Do you reduce flood risk? Do you improve temperature? All this has to be modeled, quantified. And our future projects is not just do something and see what happens. Predict what may happen now and in 20 years and so on. And this is what is now tunnel. As we speak, there is a public consultation, discussions. Our government is supporting tunnel, big tunnel below Thames, 50 meters, 8 meters, 3 double-decker in front. And they say, this is great, we will reduce river pollution. Yes, excellent. But it will cost us 5 billion, and we will have to pay all the people living not only in London, but in Reading and Thames Basin for the next 50 years, every year, £70 each of us. Well, designers have done. This is first column, what benefits you get. You get some water quality improvement, you get some biodiversity bit, you get some job creation during construction, that's it. If this £5 billion is used for, first of all, we have to do comprehensive analysis what London can do with the blue-green infrastructure, and then you get many other benefits for this 5 billion or even more or less. But you get many other benefits, and at the same time, you reduce the amount of water flowing the tunnel, and you get this water quality improvement. So just spending, this is brilliant piece of engineering. I'm a water engineer and I would like it 30 years ago. Now it's too late. We should do something differently, and this is the way to go. Unfortunately, we are not having luck. Our government ministers don't listen to this philosophy, and they don't listen to practically all academic world in this country. They carry on tunnel best, and I think this has to be changed, at least in my humble opinion. So London has a unique chance. So I'm working in London for 20 years. This big project, Blue Green Dream, is brought all the leading European architects, engineers, and so on. And I'm about to finish. And we think London has a unique chance to embrace this philosophy, be a global leader, implement it, and so on, or let the other take this technology, start implementing, and buy from them the same technology in 10, 15 years. This happened a few times in the past. I would love to see this not happen this time. We can see London change this outdated governmental approach, slow uptake, confusion, disorientated, innovative, and then silo approach. We see this is as an opportunity. London can be put in driving seat and be global leader instead of being complacent and say, well, does it work? Where are the examples from the world? It's too costly. But a lot of yes, but. This is not yes, but. This is yes, let's do it. And we can be global leader. Otherwise, Dutch are very skillful with this. They're already using blue-green hat, and we started this project a year ago. They're already having New Orleans, San Francisco, Los Angeles projects over billions and billions. Whereas we think, well, does it work? Well, let's wait next election, so. So are we putting London in the driving seat? I think yes, we should do. We have all the knowledge, we have all the expertise, we have the leading academics, we have the leading designers, Arup and AECOM, and few big companies can do it, but we need, as our previous speaker, we need structure, we need philosophy, we need the governance, we need this. This is a tunnel, and we think that the future is the blue-green concept, is the mixed. You have a carbon era, you have Roman period, bronze, industrial, carbon era. I think the new era is blue-green era. Very modest, as you can see. Thank you very much.